Greetings, salutations, all those nice things. It's me, Miss Thibodeau. Just kidding. I'm actually Mr. Athide. My esteemed colleague, Miss Thibodeau's also here. Why don't you give him a wave, Miss Thibodeau? She's waving. You can't see it, but she's definitely waving. We are going to tackle some very exciting examples today. Examples involving all sorts of parallel lines and transversals and interior angles, exterior angles, all sorts. It's a blast. At this point, you just finished the previous example, and now you're starting this video with this example. So you should be giving this a try before I actually get into the how to solve it directly. So give it a try. If you haven't done so, pause the video and go for it. And welcome back. Now that you've given it a try, here's the Athide superior method of solving this thing. We know that there are two parallel lines. We know that because it's said to us in the question itself. It's said that BE is parallel to DC, but also because these cutesy little markers right here. So those tell us that those two lines are parallel. And being parallel, I like to color code them as the same color. And then I've got a couple other lines that are transversals of those parallel lines. So there's one crossing across from A to D. And there's also one going through from A to C. So there are all of our lines colored, highlighted for us so we can acknowledge them. We need to find in this questions angles 1 and 2. And we could really find them in any order, but the first thing I notice is that angle 2 seems to be a corresponding angle with 75 degrees. Furthermore, it's corresponding while they are both along parallel lines, while they're transversing parallel lines. And because of that, they must be the same. So right away, I can say angle 2 is 75 degrees. Why? Well, it's partially because they're corresponding angles. But not just corresponding angles of parallel lines with 75 degrees. If you want to write that a bit more succinctly, because I used way too many words and way too few symbols, you could instead write corresponding and then little angle symbol, whoop, plural of, there's your parallel line symbol, with 75 degrees. You can even write it this way because that's much neater writing than what I had above. There's your best option. Angle 1 we also need to find. There's a variety of ways to do that as well, but one of the things, I just love corresponding angles, and I see one right over here. It's not a target angle, but it's one that could potentially help us. You can label that as, I don't know, X. That seems like a good variable for an unknown. And X, because it's a corresponding angle with those parallel lines with the 68 degrees, X must also be 68 degrees. So that's something I know. X is 68 degrees. And knowing that X is 68 degrees equips me to find angle 1 because that lies along a straight line. That transversal's basically a 180 degree angle. So X and angle 1 must be supplementary. So I do a bit of subtraction. 180 degrees minus X, so 180 degrees minus 68 degrees gives us angle 1, which is 112 degrees. So angle 1 is supplementary to X. And that is this example, DUN done. On the next page is another example, which again, you should be trying. So if you've not given example 4 a try, whoop, there it is. Neither have I. You should give that a try right now. I'm assuming you paused and restarted or just plowed through because you already did the example. Wow, that's great. Good job. Keep it up. Here I come. I've got some parallel lines. I haven't even read the question yet. I'm just going to highlight these parallel lines and see what happens. So I'll highlight that. I'll highlight this one. And again, I know they're parallel lines because of these cutesy little markers. Look at those. And then, of course, it also says right here, PS is parallel to QR. So number of ways for us to know that. There seem to be some transversals here. There's one of these that goes from Q to S. That exists. There's one of these that goes from Q to P. And another one that goes from S to R. At some point I should actually read the question here. Trapezoid PQRS, PS is parallel to QR. What are the measures of angles 1 and 2? Justify how you know. So that's kind of the same vibe as these questions tend to be. Angles 1 and 2. Looks like we have enough information to solve for these in any order we want. Bunch of ways we can go. First thing I personally see is that we've got a triangle. And we know that the sum of the interior angles of a triangle has to be 180. I know 2 of those angles, so I can lop them off from 180 to get angle 1. So we're using the fact that angles in a triangle add to 180 degrees. So I take 180 degrees, I subtract 24, I subtract 133, and the result is angle 1. And according to my calculator, beep boop, that's 23 degrees. Which you all obviously got before I started showing this part. So props to you. Give yourself a way high five. Good job. Angle 2. There's a couple ways we can get that. If you're a big triangle fan, you might notice angle 2 is part of this triangle, for which we also know 2 angles. We know that one angle is 67 degrees. We know one angle is 90. So we can use that same property to find angle 2. We take 180 degrees, we take away the 90, we take away the 67, and we end up with 23 degrees. It is worth noting, though, there's another way to get angle 2, and that's where these parallel lines come into play. Their relevance is that they give us alternate interior angles of parallel lines. So here's our parallel lines. Here's a transversal that goes through them, and that alternate interior property, that's kind of Z property, means that these 2 angles must be identical. So the other property you can use is that it's an alternate interior. Alternate interior angles of parallel lines with angle 1. That example is DUN done. So multiple ways to get our answer in that case, but still give us the same result. If you'd found angle 2 first, then you could have used that same alternate interior angle property to get angle 1 next, but you can also just use that triangle property. Handy stuff. Last example, once again, if you've not given it a try yet, give it a try already. What are you doing? Pause the video. All right, you paused, you started. Good. We're filling in every single missing angle here. It's given that the lines are parallel. Which lines, you wonder? Well, obviously not the ones that are crossing each other, because they can't be parallel. So those aren't parallel, those aren't parallel. Yeah, and these are going to intersect, so those aren't parallel. Your only options are the ones that actually look parallel. Generally, we can't just take it for granted and say, oh, they look parallel, therefore they are. But this question actually says there's parallel lines there. So now we can say, sure, that's true. This one doesn't require any justifications to be stated. It's just a straight up fill in everything you know. My favorite would be to start with any of the ones that kind of go across the X here. And that means that right over here, we've got 55 degrees. Also over here, we've got 123 degrees. Next up, I like to see all these supplementary ones. So this angle here is supplementary to this 55 because of that transversal crossing this 180 degree line. Or same, it's supplementary to this 55 for the exact same reason because of that line cutting across the 180. So 180 minus 55 gets us 125 degrees here. And across from it must also be 125 degrees. How are we going to get these four angles? Well, all sorts of ways. We can use alternate interior to say that this 55 matches this 55. And of course, then this 55 will match that 55. So we fill those in. Oops, 5 looks weird. And then similarly, same property, this 125 here must match that angle, which will in turn match this one down here. So all three of those, 125 degrees. To the other side, there's a whole bunch of angles in here that must be 123 degrees. Again, alternate angles. We got the 123, which must match that angle there. So that's also 123. And by that little X property, I like to always use an X's and F's and Z's. They're all over the place. This must also be 123 degrees. For these other ones, oh, these ones look cute. That one must be supplementary to the 123 degrees. Again, because it's intersecting at this 180 degree line. So 180 degrees minus 123 degrees tells us that this angle is 57. And on the other side of the X from it, way over here, must be 57. And over here, being alternate interiors, must be 57 as well. And so must this one. So all of those are 57s. There's not a whole lot of computation that has to be done for this. Just kind of spotting the sames. As long as those are spotted, then this is a real quick fill. Whew! That was a lot of examples, but I think we have completed this whole thing. There's a little peek onto the next page. Oh my gosh, there's homework. So make sure you do the homework because practice makes permanent. And if you don't, I'll be very, very upset. Wait, no, sorry. Miss T will be very, very upset. I will have no idea. This has been lovely. You have yourselves a lovely rest of the class, and be good to one another. The end.